Determine the mass flow rate of an axisymmetric plume with a convective heat release rate of 5,000 kilowatts. The fire size is 4 metres by 4 metres and the clear layer height is 7 metres. The room has only one entrance and the shop is 12 metres by 12 metres. Now, first of all, we know it's an axisymmetric plume, but not whether it's a near field or a far field model. And this is the first thing you need to do. And the rule is that if the clear layer height is greater than the longest dimension of the source times 5, then it's a far field model. If not, it's a near field model. Now, in this case, the clear layer height is 7 metres. 5 times the longest dimension of the source is 5 times 4 is 20 metres. In this case, clearly, it's not greater than 5 times the S, and so it's a near field. Now, here is the model available for the near field axisymmetric plume. M smoke equals CE, which is the coefficient of entrainment, times P, which is the perimeter of the source, times Z to the power of 1.5, which is the clear layer height. Now, to apply this model, you've got to determine the coefficient to apply, which one to apply. And there's 3 options available. You've got 0.19, you've got 0.21, or you've got 0.34. Now, if it's classified as a small room parameter, then you're going to use 0.34 as your coefficient. So how do you determine whether or not it's classified as a small room? Well, in this case, rooms are considered small when the maximum room dimension is less than or equal to 5 times the diameter of the design fire size, and the second parameter is the air can only come in from one direction. So that's the parameters, air from one direction. Now, in this case, air can enter from only one direction, and the maximum room dimension is 12 metres. Now, 5 times the longest dimension of the source, which is 5 times 4, which is 20. So can you understand it's 20 and it's the longest dimension of the source is 12. In this case, it's less, and therefore this is classified as a small room. So in this case, the maximum room dimension, 12, is less than 5 times the longest dimension of the source at 20, so it's classified as a small room. And in this way, the coefficient to use now is 0.34. So let's put that in the formula, 0.34. You've got mass flow rate of smoke is 0.34 times 4 plus 4 plus 4 plus 4, multiplied by your clear layer height, which is 7 to the power of 1.5, and you get 100.75 kilograms a second. So that is the mass flow rate of smoke for that calculation, mainly because it's actually classified as a small room and you're using a higher coefficient of entrainment.